Exercise 504 is called the Sine Rule. Now, the most significant thing about the Sine Rule is that it is used in a triangle that is now not right-angled. We no longer have to have a right-angled triangle to be able to apply our trig rules. So, new equation and a new situation for the triangles. Previously, as you know, always had to have a right angle triangle because sine was opposite over hypotenuse, had to have a right angle triangle to name the hypotenuse. Now, this is the rule that you can use when you don't have a right angle triangle. The good thing about the rule is it is on the formula sheet. So it's written as A on sine A is B on sine B equals C on sine C. Don't be put off by the fact that it looks quite complicated with two equal signs, etc., because in fact you're actually not going to be ever using two equal signs, and in fact we could actually totally ignore that last section. And if all you, and which you probably will, only ever use is A on sine A equals B on sine B. But I'll show you now how really the sine rule can use any letters. So it doesn't have to be A, B and C. And it's all based on a universal notation for triangles, in that if we always should label the points with capital letters. So if I went X, Y and Z, then, and using capital, then the sides opposite that angle, so the side opposite angle X, that's this side here, should be labelled with the lowercase x. This becomes side X. Likewise, this side over here becomes side Y, and this side here becomes lowercase z. Now I'll do it that way just so that it distinguishes from the normal printed lowercase z, because it looks like a capital. Now, what I could write about this triangle, obviously, is the sine rule, and it would look like x on sine x equals y on sine y. There is nothing special about A, B and C, and that is why, in fact, we could do every question and never introduce C. We could do every question and just use X and Y. Now, let's look more closely at the rule. What is it actually saying? It's saying that we've got two fractions and we know that they're equal, and they will always be equal. What do the fractions look like? The fraction is made up of, well, we've just said lowercase x is a side. Side x. And if you put the length of that side x over the sine of angle x, then that will always equal, in fact, any other side. So side y over the sine of angle y. And that's it. You can see there that we have four components, or four variables. Now, that would create a nice equation for us. A fraction equals fraction equation. If I knew the value of 3 out of the 4, which we saw back in the algebra chapter, if you know all but one of the pronumerals here, if you know all but one of the variables, then you'll create an equation you can solve, and that's exactly what we're going to do and will happen. So let's have a look at this example. Step 1, I would encourage you to label the given angles. So here we have 2 angles. Look, I'm just going to introduce a whole another set of letters, L and M, and as long as they're capitals, then we're following the convention of the accepted notation. And now that we've done that, let's label the sides. Label the sides as, well, they're saying A and B. Well, no, my sides won't be. They will be lowercase l, and this side is opposite M, and it'll be lowercase m. Now, use the sine rule to form an equation. So in this case, it's going to be something like side L on the sine of L equals M on the sine of M. Straight out substitution step now, where L is replaced with Y. Sine of L is replaced with sine of 51. 3.6 replaces M, and sine of 22 replaces sine of M. Looking more closely at this, yes, it's an equation and we only have one unknown. My unknown is this Y. Now, some of you will know that to solve, then you cross multiply. And when you do that, you create Y times sine 22 is 3.6 times sine 51. We want to find Y, find the value of X, correct to 2 decimal places. Divide now both sides by sine of 22 because we want the Y by itself. Now you can see that I've used the new calculator using the fraction button facility, and you can see that what I've got written here is exactly the same as what appears on the calculator. The 3.6 sine 51 over sine 22, and it's giving an answer 7.468. You're required to give the answer to 2 decimal places. I'll write the 7.468 and then round it off. And there you can see I've rounded it to 7.47. Cutting off the 8 rounds the 6 up to a 7. I'm going to stop the video there and I'll do the next example in a different video.